So now, here's our first function. Y is 1 over x minus 4 plus 3. Now, this is rational. So we have a rational function because we could add these two together and we'd get something that's a polynomial over a polynomial. I would never do that. Now, is there a value of x where this is undefined?
Yeah, 4.
At 4. Now, is it removable or non-removable? Okay, so we got non-removable.
How did you make it? Remember when it was removable? That's when you could factor out something,
Right.
right?
It's non-removable because there's no x minus 4 in the top, in the numerator. So we can't divide out x minus 4. So if it's non-removable, we get a vertical asymptote. So from there, I'll say x minus 4 is equal to 0, so x is equal to what? 4. All right, so now I have vertical asymptote here. And what I like to do is to make sure that whenever I get a piece of information I know I'm going to use, I put a box around it, or I somehow make sure that I know that that's there, because one of my problems is I'm not the neatest writer on the planet, and things kind of kind of go together. So I know my limitations, and one of them is that I have that issue. Also, another thing you can do is once you figure out a piece of information, just draw a line and go on to the next part. Is there a horizontal asymptote here? Well, let's go back to that one. But let me ask you this. If this function was just 1 over x minus 4, where would the vertical or where would the horizontal asymptote be? Horizontal. It's either going to be at the origin. Remember, if the top degree is less than the bottom degree, it's at 0. If they're the same, then you're going to get a over b, the lead coefficients, and it's going to be kind of like, well, no, it'll still be horizontal. And if the bottom is bigger than the top, then there is no horizontal asymptote. So you're saying, so the top is smaller than the bottom.
But it's the same degree.
0 and 1.
Oh, yeah.
So we should get a horizontal asymptote at 0. But what does 3 do to the entire graph?
Shifts it over 3.
Shifts it up 3. So my horizontal asymptote was at 0. Where should it end up being now? 3. So I'll put so just a little thing like that. And we'll take a look at the graph and make sure that we didn't screw it up. Now, by just finding this and saying, all right, when x equals 4, the function's not defined, we figured out the domain. The domain is every x value except for what? 4. So I know my domain is every x value but 4. The range with a rational function, it's going to be every y value except for 3. Which is good. We have that. We're good to go. Continuity, it's continuous everywhere in its domain. Rational functions are continuous everywhere in its domain. So the only place it's not continuous is at 4. Now, differentiability. What I would do if I were you, and so this is going to be our first derivative. Could we do a quotient rule? Yeah. But if I change this to x minus 4 to the negative 1 power plus 3, it becomes a power rule, doesn't it? With a chain rule.
Yes, it does.
Which is hopefully a whole lot easier. And since it's just x, hopefully it will be. So y prime, do the power rule here. negative 1 times x minus 4. Negative 1 minus 1 is negative 2. What's the derivative of 3? 0. So I get 1 over, or negative 1 over x minus 4 quantity squared.
Mr. Porter, when it like with the chain rule though, you like it was times 1, but that was exponents, right? But like that's what it would come out to.
Right.
Yeah.
Because x is just
What if
x.
it was negative x? Then it would have been times negative 1. You would have needed
Yes.
that,
Then I put a negative 1 out front. But the chain rule here, and I kind of just glossed right over it. Derivative of x minus 4, derivative of x is 1. So the chain rule would have been 1. Had no effect on it whatsoever. So that's nice. Now, is there anywhere where this is going to be equal to 0? We look at the numerator. The only time it's going to be equal to 0 if it's 0 over something. Is there any way to make that negative 1 into a 0? No. So there's no critical numbers. But are there numbers where this function does not exist? Yeah. X equals 4, the derivative doesn't exist. That actually becomes a de facto critical number. We can use this critical number even though we know the function doesn't exist there, and we know the function doesn't exist there. So we're not going to get a maximum or a minimum value there, but we can figure out if it's increasing or decreasing. So I can still do a sign test at 4. So my test values, what's my first test value? 0. I like that one. Test value here? 5. All right, so if I put a 0 in here, get negative 1 over 16, so that's negative. If I put a 5 in here, I get negative 1 over, well, anything squared would make it positive, so negative over positive is negative. So this tells me that it's decreasing on negative infinity to 4 and 4 to infinity. And you're saying to yourself, how can the function just be decreasing at that point? Well, when we actually see, I'll show you what the function looks like, but we were able to figure out that it is decreasing there. Now, is that horrific? Ish. Hopefully not too bad. Let's take the second derivative. I'm going to take this, y is equal to negative 1 times x minus 4 to the negative 2, and I want to take that derivative because that would be a whole lot easier to take a derivative of than do a quotient rule, even though the quotient rule will work out just fine. So this is going to be y is equal to negative 2 times negative 1 is 2 times x minus 4 to the negative 3. Chain rule, derivative of x is 1. So, and I forgot to put double primes in there. So y double prime is equal to 2 over x minus 4 to the third power. Now, where does this not exist? At 4. So x equals 4 is still the problem child. So I can take this at 4, even though it doesn't really work as a point of inflection, even though it's, like I said, it's a de facto point of inflection, but it's going to be more so telling us what's happening to the left and what's happening to the right. And sorry, I'm just moving stuff over here. So this is going to give us information more so than this is a point where it's changing concavity. It could be changing concavity, or it could not be changing concavity. Let's take a look. I'll use the same test points. 0, which would be negative 4. Negative 4 to the third power, is it going to be positive or negative? Negative. Because it would be negative 4 times negative 4, which is positive, times another negative, which is negative. So does that mean it's concave up or down? All right, so I know it's concave down on negative infinity to 4. Now, if I plugged in a 5, 5 minus 4 is 1, so that's positive. Anything to a positive number to any power is positive. So it's positive here, so I know it's concave. Yeah, it's concave up on 4 to infinity. So we were able to figure out all sorts of different things here. Now, let's take a look at how we want to summarize this. And I would say, do we have any x-intercepts? Where's the x-intercept? No. X-intercept is where y is equal to 0, correct? So I put 0 is equal to 1 over x minus 4 plus 3. So subtract 3 from both sides. I'll do that. What's 1 times 1? 1 is equal to negative 3x plus 12. Good to go so far? Subtract 12. $11 is equal to negative 3x. X is equal to negative 11 over 3, which if we wanted to really say this is going to be equal to negative 2.6 repeating. Sorry. See? Worked out perfect. So, I know 2.6 repeating 0. Do I have any y-intercepts? That's where x is equal to 0. So y would be equal to 1 over 0 minus 4 plus 3. So y is equal to negative 1/4 plus 3. So 3 minus a quarter. So y equals 2.75. So I get 0, 2.75. Does that make sense? All right, now let's summarize. Zoom out here. The summary, x-intercept, 2.6 repeating 0. Y-intercept, 0, 2.75. And we'll be checking to see if those work. Let's see here. Did I get a vertical asymptote? X equals 4. Did I get a horizontal asymptote? I hope it's y equals 3. I'll be honest, I'm usually very poor with horizontal asymptotes. Now, increasing. Do I know where the function's increasing? Where? It's not. Is it decreasing? Now, is it concave up anywhere? 4 to infinity? Is it concave down? Negative infinity to 4. Are there any points? the intercepts. We already got those. But the up here, even though we were able to use that to determine concavity, that's where a vertical asymptote exists. So there's going to be no point there on the graph. So now let's take a look at the graph itself. I got all that information. Let's see what we got. Yeah. Yep. All right. 1 divided by x minus 4 plus 3. Now, let me see if I can put a vertical line in here. Yeah. There are no extrema. When we took the first derivative, we couldn't set it equal to 0 and get a number. So there was no extrema, but there was that one point where it doesn't exist. So we use that to kind of figure out what's going on. Now here it's decreasing. Does that match up with our interval for decreasing? There's 4. Alright, so here, let me put a line in there. Click 2 points. Alright, x is 4. Enter, y is 8. And then I want x is 4, y is negative 8. Let's go negative 4. Alright, so there's my asymptote. Does that, and that's, if I wanted to calculate actions, equations, there it is, x equals 4. Does that make sense that we got what we needed to get out of that? Alright. Now, if I plotted y equals 3, is that the vertical asymptote? And I want to make sure that the points on were the points that we got. So I'll click this graph, open it up. 2.6 repeating, that was, what was that, 11 over 3?
Yeah.
All right, so if I go 11 divided by 3, 0. Was that one of the points that we wanted? All right, so far so good. I want another point. Make sure my x value is 0, and I got 11 fourths. Is that what we got before? 2.75. That's 11 fourths. So does it look like everything is working out? Yeah, everything ended up working out nicely. The only thing different that you're going to have to do is, well, one, you'd have to make sure that this graph those two lines are dotted and dashed, or dotted and dashed, however you want to draw them. It's fine with me, sir. Because I basically skipped that. No. goes to infinity of 1 over x minus 4 plus 3. Make it fast. Now, if I plug in infinity to x, 1 over infinity, what's that? 0. Plus 3, isn't it? So this would be equal to 0 plus 3, which is 3. So as x goes to infinity, what's the value right here? 3. Is that what's happening? Is the graph going towards 3? Sort of. It is. Remember, just because I said it's going towards 3, it doesn't mean it has to hit 3. It's never going to hit 3, actually. If I go to negative infinity, 1 over x minus 4 plus 3, this would be equal to 1 over negative infinity plus 3. Is it going towards 3? Yeah, because this would be 0 plus 3, which is 3. So that says this guy right here is going towards 3. Is that going towards 3? It's going towards negative infinity, but this value right here is 3. So the graph here is going towards 3, even as it's going towards negative infinity. So we were able to take that value and take the limit on both sides and kind of verify what we were doing with that.